if we have a function, and this function has a Fourier integral representation, which looks like this: f of omega e to I omega t d omega. Now this f of omega in the integral representation, the Fourier integral representation, is what is called the Fourier transform of f of t. And to find it, basically plug your function f of t, and just as you did in Laplace transformation, with a little bit of change, this will be your Fourier transform. Okay, let's have an example. Let's say the function f of t is equal to a unit step function into e to minus t. Now this function may look like this, because the unit step function cancels out all the negative values. So basically we will change the interval of integration and make it from 0 to minus 2 plus infinity, and plug in this value into f of t. So I'm sorry, because we already used or utilized the step function by changing the interval of integration. So what is left is e to the power minus t and e to minus I omega t dt. Now multiplying the two exponential, the bases, and adding the indices, and this gives 1 plus I omega. Performing the integration gives e to minus t 1 plus I omega divided by minus 1 plus I omega from 0 to plus infinity. Now when you plug in plus infinity here, evaluating plus infinity, you will get 0, because e to minus infinity is 0. Hence the whole expression will be 0, and this is minus. Now evaluating 0, and this will give you 1 over minus 1 plus I omega, which is 1 plus 1 divided by 1 plus I omega. So this is the Fourier transform of this function.